I joked with him that he took all the good answers. So we'll see how I do here, giving you something unique.
You started as a research assistant, went into the industry and content creation, then senior robotics engineer. So, how do you feel about this?
It's hard to choose, right? My first piece of advice is like, don't look at what other people think is cooler. It should really be like where you want to focus and you should do it.
The space is changing so fast that you don't have any other option.
Absolutely. So basically my whole thing was about, having a passable set of, navigation or manipulation skills so that little dent in perception, for example, could actually be shown in a compelling demo.
So, what would you like if you want to hire someone? What should he be doing?
If I want to hire someone, I look mostly for other types of skills that are not just like how much technical knowledge you have today.
I have a robotic arm. It's a 3 degrees of freedom robotic arm, and I 3D printed it, installed servos inside of it, and we are using a Raspberry Pi to control it. I have created from scratch. What do you think about this guy?
If I were interviewing this person, right, I would basically just start digging into them a little bit to see how much they actually understood the OMPL part. I don't want to give people the impression that like you're not yet mid-level, you should like give up, like you're only junior.
Humanoid robots, that is bugging a lot of people, that this is the new thing and all other robots are going to die. Only humanoid robots are going to be the face of robotics.
Actually, I have a little humanoid figure here. This is from PAL Robotics, so I've been playing with it. So humanoids, we just haven't gotten to the point in the maturity of humanoids that...
What do you think about AI and robotics specifically?
It's certainly happening. Obviously, AI is not like a monolithic thing, so there are certain aspects of that field where people are more mature than others, right? There's lots of companies that are doing this. Like, are those ready for production? I don't think so. A lot of these are demos.
Hello everyone, we have Sebastian Castro with us. He is a robotics and applied scientist at AI Institute currently. He has been serving as a senior robotics engineer at Boston Dynamics and Picnic, which we formerly known about manipulation of robotic arms. So let's get into this podcast and learn more about his journey into robotics and what he's currently doing. So Sebastian, how are you?
Doing great. Happy to be here. Thanks for this opportunity. One thing I will say, I was messaging with Josh Newens, who you talked to previously, and I joked with him that he took all the good answers. So we'll see how I do here, giving you something unique.
It's amazing. And it's quite interesting that both of you are in contact, and because both of you are doing amazing stuff. We all know you by your MATLAB work, the content that you have been producing for MATLAB about robotics, and it was very useful, the in-depth guide, because most of the time you get into robotics, MATLAB terms that used are not robotics oriented in the tutorials available mostly, but your content helped a lot. Thinking about your journey, you started as a research assistant, went into the industry, and then went into MATLAB content creation, then senior robotics engineer. So how do you feel about this long journey of robotics development?
Yeah, it was certainly a detour, right? In my MathWorks career, so MathWorks was a place where I went to directly after I finished my master's. And there, the kind of tension at the beginning was constant between, do I want to do more development side type of work, or do I want to do more education type of work? Because I've, really enjoyed both. So even like the videos that you're referring to that was already about 5 years into my career at MathWorks. It just happened that I wasn't doing, like public outreach type work before. So I used to work on the training team there, developing course materials for MATLAB and Simulink. And at some point, I transitioned to a role where, the content we're producing was actually visible by people online. And so I'm glad that you recognize that. I think one of the cool and also really challenging parts of that was, as you said, that MATLAB didn't really have much of a foothold in the space of robotics, right? So it was around the 2015, like end of 2015, when MATLAB officially released its robotics system toolbox, which in part contained some robotics algorithms. It contained a ROS interface. And then, me and one of my colleagues decided like we need to, start using this and talking about it. And that transitioned into the role that you recognize me from, where I was working more with like robotics competitions around the world and like sharing videos and blogs and educational content in general.
Amazing, amazing. At certain point, I looked into it that you went into the UAVs domain as well. That's interesting. And then you came back to manipulation side. So how was the shift?
Yeah, so that was actually between those two roles that I told you about at MathWorks. I did try out working at a company based on UAVs. That was an interesting role, right? I spent a bit of time working on modeling and simulation for basically an autonomous drone that was solar powered and needed to harness energy to basically stay afloat or stay in the air. But yeah, then I was kind of lured back by this, you get to work with robotics competitions worldwide. You get to travel and make materials. So that was again, like going back to what I started with, that there was this tension between doing engineering and education, and that's still something that very much defines my career even today.
So, okay, as your current role as an applied scientist, it's now coming back to education side or research side?
It's research side, but as I've been doing a lot of the educational stuff on this side. So basically, the MathWorks work that I was doing gave me kind of an initial platform because I was, putting out content and people were sort of recognizing the work that we did. So after that, in 2020, when I started doing research and then throughout the different jobs that I've had since then, that's where I started doing my own education stuff on the side to kind of scratch that itch. So you might have seen that I also have my own like personal blogs and open source repos that are completely separate from the work that I do for my day job.
Interesting. So if a person is starting, he is a master's in robotics related field, and the experience that you have as a research assistant or research side when you were starting, and the engineer that you became as a senior robotics engineer at Picnic. So what do you desire the most? If you start again, what you would select opinion about your experiences, the development side or research side?
It's hard to choose, right? I think I still have a preference towards the development side. And a big reason is sort of, through different things that I've tried, I've thought of, what do I enjoy doing the most? So maybe that's like my first piece of advice is like, don't look at what other people think is cooler. Like if everyone tells you, no, you have to be doing research because that's where, the future is, whatever. I mean, it should really be like where you want to focus. And if you agree with that, then you should do it. So for me, it was always that, right? Like, should I be doing more cutting edge work? Should I be doing more engineering? And generally I found that I don't know, the strength of mine that I found over the years is that I like to take concepts that are pretty well established, things like algorithms or just foundational math behind certain parts of robotics, making them accessible to other people. And that translates to maybe having like better software tooling so that people have that base covered when they're doing their own cutting edge exploration. So even in my current role, right, when I'm doing research, I'm really in the portion where I'm sort of contributing to research by giving people lots of engineering support. And that's sort of a space that I like to be in. I think other people have better novel ideas than I do. And that's okay. Like I have my own thing I'm good at.
Interesting, interesting. Education and research is more closer to you than development for now. But I think nowadays what we are experiencing is that the space is changing so fast that you don't have any other option. Even if you are a developer, you have to be a good researcher as well. At the same time, as things are getting integrated, the AI boom that we will be discussing later. So coming to your time at Boston Dynamics, as it's a very popular company and people look forward to as a dream job as a robotics engineer at Boston Dynamics because of the Atlas robot and its funny videos. So working in such a company, which is a world-class company, and before that doing research, do you have any experience differences between these two because of the development scope that you are building as a product or things like that?
Absolutely. So basically, before I joined Boston Dynamics, which was an awesome opportunity, I was doing research, and the point of research is really you're trying to show, like, for each item of research you're producing, it tends to be some novel piece of work or some system you're showing, right? So in the case of showing novel advancements in AI, which was a focus of the research work I was doing at MIT, if you have, for example, a new perception algorithm, you still need a robot to have all the other basic capabilities before it even works, right? So my whole thing was about having a passable set of navigation or manipulation skills so that little dent in perception, for example, could actually be shown in a compelling demo. But the key thing with research is, you need that demo. In Boston Dynamics, it doesn't really stop at that demo, particularly in the team that I was working on, which was the Stretch warehouse robot. Like,
Okay.
it's not quite the same as the more demo-oriented undertakings of the company. We're really trying to go out there and like put things out in the real world, like with real customers. So you can't hide behind the like veil of the demo in that sense. The dedication to just having like really good robustness for your robot, making sure that it never got stuck, that if it failed, you knew exactly why, that you had all these fantastic tools for logging and introspecting and debugging just what the robot was thinking. That was like a massive difference. And the amount of dedication that Boston Dynamics has to making really robust robots is, like you said, not really paralleled.
Definitely. So I also experience this problem in the people I interact with and the communities I am here. The research domain guys are trying to solve a lot of important problems, but they're not actually solving the real problems. As compared to the companies, they are directly solving the problems which current customers and people are facing. So I think research is for the future, but this is a tricky part. Future is changing so rapidly. What you can be researching about the future. So how do you decide between these things? Which one should one be choosing?
That I think again boils down to I guess your preference and your strengths, right? Like obviously, if I were to put myself in like a perfect position where I'm the, a noble person and I'm completely selfless, then obviously you would always solve the immediate problem today, right? But I think it is worthwhile in general to have like a world in which, there's a portion of people that are working on, real actionable problems and a portion of people really investigating new technologies that can later be used for addressing these problems, right? You're kind of pointing to that is really tough in research is if you have this new technique, you need to come up with a good application, and people will often default to very similar applications like, oh, we're going to, focus on search and rescue for outdoor robots to show off our new, localization algorithm. We're going to focus on home robotics, robots in the home for, people with disabilities or elderly people to show off my new, language processing algorithm. You do have to be a little bit contrived and you do have to make up these scenarios and they might not like directly be exactly the problem that society needs, but I think it serves a good purpose in the long run. I do think that
Interesting.
research in general needs to pay more attention to the types of tasks or problems to solve before, like having the
Okay.
approach and all the demos ready to go. But generally there's a good breakdown, right? Where once your technology starts to show promise in simple problems, then you should really start thinking about like, okay, what is a good compelling use case that actually can be, people can at least link to a real problem 5-10 years down the line.
That's a tough thing to do,
Yeah.
actually, in such current space that we are working in. Things are changing rapidly. We'll discuss the AI part later on. Coming back to your development experiences, what major shifts that you observe from robotics engineer to a senior robotics engineer?
Hmm. That's a good one. I actually wrote an article about this at some point because I was like coming to terms with that myself. And I think that the ultimate thing is that a, regular prefixed robotics engineer is really worried about, producing good work and doing the work for themselves, right? Like you are assigned a task, you make sure you do a good job at it. That's a good engineer, right? The senior engineer is more about, working with others. So there's quite a lot more mentoring of people, working with more leadership type roles to actually have an input on what the task should be and what the vision should be. So it's not so much that you're like one-sided receiving tasks. It's like you're negotiating with more people, making sure that, the rest of your team is not really stuck or going down the wrong direction. And the tricky part is that this is all at the same time as you also doing your own work. So it becomes an interesting time management exercise. It's a big difference, right? Like the things you worry about just like expand. But
Okay.
if you're working on something that you find exciting, it does mean you get to just take more part of it. So it can be a good thing. I'm not saying it's like, the stress is unwarranted, but it just is more responsibilities.
More responsibilities, and can we say that less development side?
Necessarily yes, but like I think the like ideal standard is that even though you're spending less hours developing, because of your experience, you're actually still able to produce equivalent output, right? It might be that when
Okay,
you were a
yeah.
junior engineer, it took you, a week to do a task, and as a senior engineer, once you kind of know what's going on, it might take you a day, so you can spend the other 4 days, doing other stuff. It's more of like an efficiency thing if done right. Like I think, that's the ideal. How it actually shakes out depends a lot on the type of environment you're in, the type of projects you have to do, etc.
Interesting. So going a step back, a non-robotics engineer to a robotics engineer in an industry. A non-robotics engineer meaning a person who is doing hobby projects and building things. So what is the experience between this step?
There are so many. Well, I think so. You actually made a comment a few minutes ago that was saying that you were saying that every developer now also has to be a researcher because robotics is so complex and integrated, but it also works the other way, right? I think that anyone who's like a robotics applied person has to be like an okay programmer as well. And that's a big thing in robotics. I mean, that has some exceptions, like if you're really focused on like the hardware side and design side, maybe not, but even then people are transitioning from using, just like point and click CAD to more like procedural generated stuff, everyone's trying to automate things with scripts that, you can ask ChatGPT to help you write, etc. So that's one change. You said a hobbyist in robotics to a professional in robotics. I think there's just a giant difference when you're working on like your own project and your own repo versus having to collaborate with others. When you're working on your own, like any change you make, you can keep in your head, you can keep track of it. If you break something, you break your own thing, then you go fix it. But on a team, it becomes a little more complicated, right? You have to make sure that you're not like stepping on someone else's toes or developing things that are in conflict. And generally, yeah, just like you need that balance between like moving quickly yourself but not slowing other people down. And I think that's very hard for people to do, especially if you've just come from a place where you're like working individually in your own hub, right? Like you see this a lot with people that like have just come out of grad school and go right to industry.
Okay, interesting. So as people start into robotics, mostly they start with mobile robots because they are easy, they are affordable. And when they look at tools like MATLAB, ROS, they provide a lot of things. I mean, everything, mapping, navigation. So what's your advice to the people who are just starting out? Do they need to learn algorithms, or they can just, as a hobby project, they can complete the project first and then try to understand the algorithms?
That's also a pretty hard question, right? Because like ideally you have infinite time and you learn both the algorithms and finish the projects, right? Like you do everything. But under the constraint of time, I'd again, like this may be just like my one answer that I have for this whole interview, but you should boil it down to what your preference is, right? Like if you are doing a hobby project because you want to see, you're interested in learning navigation algorithms, but you want to see how they apply to the real platform. That's a great mentality to have. Don't just stay in simulation. Then maybe you want to, have like very basic hardware working so that it at least follows a path, and then you start, digging more into the algorithms. If you're interested more in, actually going through the whole like systems end-to-end process, then maybe you don't try to learn too much of the algorithms and you just try to grab pieces from different repos like Move It or Navigation, and that's also the case. Like we're talking about solving real problems and doing, more application side development. There's a lot of companies out there that, they're not primarily formed by robotics engineers. They're saying, hey, I have this problem. Let's say, I want to automate kitchen preparation for fast food. My primary goal is to solve that problem, and I'm going to try automate it with robots. Should you care that much about algorithms first, or do you just need something that kind of works and then you later optimize? Yeah, I mean, there's no single answer, unfortunately. I think like with everything, there's like, 1,000 things to learn, and you should, just pick a few to start with and then, do more later.
Okay, let's put boundaries around it. So what would you like if you want to hire someone? What should he be doing?
If I want to hire someone, like, yeah, you need to have baseline technical skills, but my biggest thing, and I also have an article about this, I think you've made a video about this as well, but I look mostly for other types of skills that are not just like how much technical knowledge you have today. It is how well do I think you're going to be at learning new information and like making sure that problems are solved well, right? And that involves, to be very reductive, just an ability to Google the problem or ChatGPT the problem. Like if you can, if you can take a problem that is maybe not so well defined, that has a lot of variance and parameters to explore, and you can kind of go off on your own and figure something out, that's great. And also, the other thing I say in the article is I don't necessarily want someone that just like wants to like go through as many tasks as quickly as possible. I've worked with a lot of junior people that think that that's the way to like impress your mentors, right? That like, oh my gosh, you did it so quickly, that's amazing. But what I really care about is not that. It's how do you know that you finished, right? Like, did you establish any like testing or any way to check your work or like videos that show that the thing actually works, or is it that the code compiles and it's done? That those two skills I think are way more important to me than like what you know today. It's more about what I think you can like get to in the future.
Interesting and important advice. Yes, the video that I produced about advice for a young engineer, this was the title. It's amazing, and I recommend everyone to read that article. It's on Robotics Seabase. That's the name of the blog.
Yep, roboticscbase.com. It's
coming to the side of more towards the development, as we have MATLAB, ROS2, ISXM, and some other tools as well, but these three are very popular. So they have different powers. And what do you think about this? Someone is getting into robotics and now he wants to learn robotics. He reads books. What should be the steps towards the tools he should be taking, and which tool will be helping him to become a good First of all, let's start with research. How can he get better at research? With which tool?
The main tool you should get good at is researching information. Like, because the problem is that depending on what you're doing, the tool may not be the best or maybe the best. That being said, there are like certain guidelines that I can provide that are more like a quick answer for tooling, right? I think in like the core robotics space, there's basically programming languages and there are software tools or software frameworks, right? As far as programming languages, the main ones that you'd see today are largely going to be C++, Python, and MATLAB, probably in that order. The like MATLAB and Python side is more on the, you maybe want to like prove out some algorithms and do some prototyping, but then each of those two programming languages also has its own attached frameworks that make it useful in small pockets, right? Like MATLAB and MATLAB adjacent products are really good at like the control space, for example, or like, low-level simulation of like mechatronics or hydraulics type stuff. Python, of course, harbors today the biggest machine learning ecosystem. So if you're doing machine learning, you probably want to pick Python. And then on the C++ side, I think, unless you're doing something a bit more out there, like, using Rust for your whole stack or anything like that, most of the, on-robot deployment high performance code today runs on C++. I think the general like rule is that if you're doing any like, high frequency controls or perception type stuff, then you probably want to be looking at those system languages. And I think that kind of leads into the Rust part, right? Like, I think the key differentiator there was whether you're using, an interpreted language that makes it easy to like prototype an idea versus using a compiled language that may be harder to figure out, but is going to be more performant. And your robots generally will need a little bit of both. So tools like ROS that allow you to create, different processes and have them communicate with each other, I think are pretty important. So then you can have either your like prototyping node or your machine learning node in Python. You can have your perception stuff in C++, and they actually have a way to talk to each other that isn't you like going into the depths of all of networking yourself, right? These are like frameworks that already exist. So yeah, I think, having something like ROS to coordinate different things in different languages is a good thing to do generally in robotics. Even if it's not ROS, it's something like it.
Okay. So does it helps in the interviews or job, a junior level developer job that I'm good with ROS, and these are the things that I've done in ROS. So this helps in the interviews?
It does. Actually, one of my former bosses told me this, that was like, even if we don't use ROS, the fact that you know it because of that same reason, like the fact that you now know about, distributed nodes and having, intra-process communication. But communication between multiple processes is important, right? I think other guests that you've had have touched on the same thing. Showing that you know ROS isn't, I cloned these repos and I got it running, right? It's, I actually developed something new in addition to the tutorials or the examples, right? It's like showing that to directly steal Josh's answer is to actually show that you understand, not that you can follow rules.
Definitely.
So thank you, Josh.
Yeah, this happens a lot, and most of the people have experienced it as well. A lot of people brought this to me that asked this question specifically. Coming to the part of a bachelor's person, then a master person, and a PhD person who is shifting towards industry. So the industry perspective, what do you see the differences between this? What is the skill level? What is the depth level? How do you see these three levels of who have these degrees?
Okay, so I think what I'll do is I'll say that the bachelor's is like a baseline, and then, whether you have a master's or PhD, it depends on, there's different reasons for why you would have one or the other. But for me, mostly it means that like if you intended to get a master's from the get-go, and you just said, I just want the master's and go right to industry, then generally I see that, these are people that, myself included, right? I got a master's and went right to industry. That maybe at the end of undergrad, you finished getting like a survey of all the things in engineering. Like I studied mechanical engineering, and I found that in my first like 2 years, basically, there was like a bunch of stuff that I realized I didn't like. And it wasn't until like year 3 and 4 that I was like, oh, like I really like this like control stuff and robotics and AI. So I basically wanted to get a little bit more of that, get to maybe have more choice in my courses and get like a meaningful project under my belt before going to industry. So you basically see that, right? Like a master student generally has a bit more like project experience if they haven't, as an undergrad, like gone out and sought that, right? Some undergrads do like formula student work or, that kind of stuff. Then that like pays off amazingly. I think the PhD then teaches you the discipline to say, okay, like in undergrad and masters, you were just basically taking all these approaches and information that already exist. Like, you understand what like a PID controller is, you understand what like these computer vision algorithms are, where they're applied, go apply them. PhD is like, okay, you understand that, a lot more in depth, and now you have to make some change on top of this landscape that shows that you understand it well enough that you're doing something new. Either it's a new combination of things in like the more systems application papers, or you're like, developing new algorithms or new variations. And I think the ability to dive that deep into the literature and make, meaningful changes has a place in industry, right? Like if you're someone in industry that's been tasked with like, make my robot go as fast as possible, then you basically need to start looking into more like PhD levels of like dedication and almost obsession with like you know like
Uh,
really pushing the limits of what's out there.
okay, that's quite interesting. Okay, let me give you an example of a person, and
Mhm.
then I do this with every guest because it is very important. I'll give you a project, and then you have to tell me is a mid-level, junior level, or a senior level person. Let me think about it.
Okay.
Okay, so starting with the basic, I have a robotic arm. It's a 3 degrees of freedom robotic arm, and I 3D printed it, installed servos inside of it, and we are using a Raspberry Pi to control it. I have used OMPL library in C++. Everything is in C++. OMPL library to give the robotic arm XYZ goal coordinates, and it plans and it moves. I have created from scratch. What do you think about this guy? And what questions will you be having from this guy?
So what were the categories? It was junior, senior, and
Let's keep it to junior and mid level.
okay. Well, the fact that they did a lot from scratch is really impressive, right? But that begs the question, like I said that like, well, I guess you eliminated senior, but the thing that I'd be asking is, was this something that like the person did by themselves, or did they do it as part of a team, for example? That tells me signal about whether, you kind of have that like mid-level to senior gap, right? I guess I'd probably go for junior still, in the absence of more information. If I were interviewing this person, right, I would basically just start digging into them a little bit to see how much they actually understood the OMPL part, for example. Like if you asked about different types of sampling-based motion planning, like how they tuned it, why sampling motion planning was useful for a 3 degree of freedom arm, that kind of stuff. I'd really like to see the answers to make that decision. But also, like I don't know if I'm particularly a fan of the format, right? Because I don't want to give people the impression that like, oh, you're not yet mid-level, you should like give up, like you're only junior. Like I think everyone is at some skill level now, and like we're all working towards getting better from wherever we're standing, right? So I would probably
I
also try to
understand.
get that
Yes.
when interviewing them.
Uh,
I would really be like, what else would you do? Like, do you have any more ideas? Are you excited about this? Or did they're like, oh, I'm not going to work on this anymore. I finished my project. I have it on my resume. That's all I care about. I want the actual excitement. That's what I want.
okay, okay. Okay, okay. Obviously, when you're hiring a person, there are a lot of things. Sometimes some companies they don't have any other option, so they have to get the person and keep the project going. That's the case as well. But in obviously, if you are doing a simple some inverse kinematic thing of a robotic arm, you should be good at XYZ thing. Would you recommend certain things regarding the robotic arm? Some tech things about robotic arms that one should be really good at it.
Yeah, so robotics arms is interesting, right? Because like, I think you also said this a few minutes ago, right? That lots of people start with mobile robots because they're cheaper, they have less actuators, and also the problems are a lot easier to conceptualize. Like you're dealing with like a 2D or like 2D plus rotation, and you can actually visualize this stuff all on paper, right? Like the state space of your motion planning is very easy to translate to the actual like, position in the real world of the robot. With manipulators, because you have more degrees of freedom, it's a more nonlinear system. It's hard to translate like what the joint angles mean in terms of the position of your hand, for example, of your gripper. So that is a big logical leap that unfortunately just has a lot of math behind it. I think there's lots of resources out there, though not as much as for other robotic systems, right? There are some great freely available online courses from Northwestern University. There's Rust Hedrake's courses from MIT on manipulation and under-actuated robotics, and I think those two are like some of the best things out there for robot arms. I've also made my own attempt at like pulling this stuff together, so I have another very long article about how do robot manipulators move, and I mentioned some of these resources and try to at least give you some pointers to the math, but I don't go into the details, right? I basically say like these are the basic concepts. Here are some papers or books that you should like, if you want to get like really deep into this, go dive in. And then the other thing, like there's also lots of software tools out there that let you experiment with, you can like load a robot arm from one of these like URDF models. So I would encourage people to just try that out, like for example, there's a really nice tool that I use called Pinocchio that in one of its tutorials, it has you implement like your own inverse kinematic solver for like a 6-degree freedom arm. And that's like super useful. Like, you can get a lot from that.
Okay, interesting. So how do you implement it from right from scratch or using a library?
It's using this Pinocchio library. So
Okay,
Pinocchio basically gives you a couple of the basic pieces. Like it already gives you like forward kinematics and Jacobian calculations, right? So the part that you implement is the optimization that says, okay, given, at this joint state, my forward kinematics tells me I'm here, but my target is here, so the error needs to get translated through the Jacobian to the joint error, and then you have the optimization step. So that's
interesting.
like super good to learn. Yeah, and then maybe if you're thinking of making a video, then like going through that gradient descent based IK is, I think this is one thing with like the manipulator and humanoid space, that the people there are so advanced that they forget that these things are not obvious for newcomers. And like they'll say like, yeah, of course it's gradient descent, like Jacobian transpose, whatever. But yeah, like there's people that are desperately looking for this information. And I
Yeah,
think that's the way
definitely.
you get more people in the space.
And one very important thing that I want to bring up is, as you mentioned, the Northwest University book. It's amazing and it's free, available. Video lectures are also available. But
Yeah.
when you open the book, the maths that is written, it scares a lot of people. Obviously, in practice, even if you want to move a single mobile robot, differential drive, two motors robot, there is a lot of maths behind it. So how can we compress how can we not scare people and give a solution to those people, because shifting from maths to C++ is the biggest jump in starting. So how can we deal with that?
That's hard because I've definitely gone through my own periods of being intimidated by math and being paralyzed by it. And so I'll give you one example to like encourage people. There was one thing that I never really understood, which was when you're doing these kind of IK type solvers, how do you also do collision avoidance? Don't know. Like I asked a bunch of people, they gave me some answers and some resources, and I spent, I was doing other stuff, but I spent, years being like, oh man, like every time that I was, like in the shower, sometimes thinking like, oh man, I still don't know how you do collision avoidance. Like I don't get it. And at some point I said, like I'm just gonna like sit down and carve out the time. I like went through a couple more papers, and then by the time I felt okay to try something, I spent maybe 3 hours on it, and just like in front of VS Code, just like hacking something out in Python. And I was like, oh, I didn't solve the problem fully, but it started to make sense. So I think math in general can be really intimidating, but I think you just have to. I would say that like if you can't understand it right away, it's not because you are any less of a good engineer. It's that these things are actually hard, and like hard things just take time. That's one thing. That being said, there are ways to make stuff more accessible. Whenever you read these textbooks, I think it's important to couple these with like examples. So, I think the Northwestern book does have at least they have some MATLAB files that also like accompany the book. But generally, it also goes a long way. Like, don't just give people the math, but also give somebody an example that they can modify, right? Like if you're talking about inverse kinematics, can you give them, like the little like gradient descent step to modify, for example, to see how that impacts the robot? Or maybe another exercise is like, oh yeah, I've shown you how to do this for a 6-degree freedom 6-degree freedom robot arm. Can you load this new robot model and make it work there? And you can see how this extends to like generic robots.
Interesting. So I'll ask a project from you and I want you to give insights into it. If I have a robotic arm, that robotic arm has a camera that is looking on the table, and there are things on the table that robotic arm has to pick and place like an industry setting. So from a senior robotics engineer perspective, what is going to be the software that you will be planning? What are the steps that you will be looking forward to? And how will you solve what tools that you will be using throughout this process?
Yeah. For me, I would solve it very, very incrementally. There is a
Okay.
tendency, and this is maybe very important, a tendency amongst junior engineers or people with less experience that given this problem, it's like, well, obviously I'm gonna like immediately start downloading all the latest machine learning models and get the fanciest algorithms and get this thing working, right? And then you spend, multiple weeks trying to get all this to compile, and you still have made no progress. So I would not do that. So you're talking about pick and place from camera, right? I would basically start by saying, okay, well, let me first assume that I know exactly where the object is, right? So I'm just gonna like in my experiments, I'm gonna put the object on the table, I'm gonna record that position, and I'm gonna see if I can get my robot to plan, do the whole like move, pick, place, put it down. Does that work? Great. If it does, then we have to start thinking about how you how you get the pose of the object without knowing it up front, right? And then my recommendation there is, or what I would do is I would go as simple as the problem lets me do it, right? If I'm doing this in like a warehouse setting where, the objects have like QR codes on them or something, then maybe I can use that as a fiducial marker and just go pick based on that. Maybe I'm doing an assembly task where all the parts that are coming in, I already have CAD models for them. So maybe I'll do like a point cloud registration type thing so I can get really good localization. If I don't have that, then maybe we should start thinking about getting more geometric or machine learning approaches, right? Like if the objects are always like a regular cube shape on a tabletop, then maybe I can use geometric approaches where I can, segment out the table, detect cubes, and then do a grasp based on the cube. If I'm picking generic objects, then okay, maybe now I start thinking about, getting some of these like pre-trained foundation models. So definitely start simple, because it also makes it less stressful that way. If you're at least like, every couple days or every couple weeks, you're actually like, having some progress to show. You're not just like, stuck for months until it finally all works. It just feels better. It also shows better for your boss or your leadership in general that you're making steady progress.
Interesting. Yes, definitely. We have to think in that way. So the top leadership understand that and something is happening. So for robotic arms, what are the top libraries that are good for planning and optimizing for production level quality?
Well, so basically optimizing, like to give watchers a little bit of background, motion planning can be done. I guess there's two major camps of motion planning, right? There's the sampling based motion planning, where, as the name says, you just basically pick a bunch of random points and try to connect them. There are ways to sample more intelligently, but that's the basic thing. So these are like the OMPL type libraries. Of course, the biggest host of OMPL is the MoveIt framework, which is just like a generic ROS framework for manipulators, but it happens to have good support for OMPL, among other things. As far as optimization-based planning, which is, instead of sampling, can you actually start with like an initial guess of your path and actually use, a mathematical formulation to actually like reduce the cost or comply with constraints. Easily the most capable tool for that has a lot of cutting edge approaches is a tool called Drake. That's also from Russ Hedrake's lab and used heavily by Toyota Research Institute, for whom he's one of the heads of research. That tool is very capable, but it can be a little challenging to use. Luckily, it has a Python bindings as well. We've actually like this summer, we were mentoring a project where people tried to combine MoveIt and Drake. So one of the guys we mentored, his name's Aditya, is a PhD student in Edinburgh. He developed an interface so that you could call Drake motion planners from MoveIt so that you get the ROS interface that MoveIt offers. So like connectivity with the ROS ecosystem, but also you get the optimization-based planning or other tools. One other optimization tool in the ROS ecosystem that is good is called Tesseract. So it's very similar to MoveIt in concept, but it was designed by some of the ROS industrial folks, and they put a lot, like in the same way that MoveIt has a lot of weight in OMPL, Tesseract puts a lot of weight into this optimization framework called TrajOpt, which is the use of sequential quadratic optimization to solve for trajectories for robots. So they have some really cool examples of TrajOpt being applied.
That's nice. Some new words that I am hearing. I'll write it down. Coming to ROS and ROS Industrial, what's the difference between these two frameworks? Or is there any?
I don't think there's a big difference. I mean, I'm maybe not the best person to ask. I may give a partially correct answer, so just for watchers out there, but basically ROS is the framework that underpins all of this, right? It's, the build system, the inter-process communication mechanism, the packages. But there are lots of groups within the ROS ecosystem that are trying to push on more of their applications, right? So ROS Industrial is a consortium of people, usually from, representing companies that are trying to do, automation type work for industry, but other research institutes that focus a lot on these applications. And they're trying to basically connect, the ROS world, which started very, academic, very high level programming, to what more automation engineers in industry are doing, things like PLCs, for example. So there's a lot of, effort into trying to bridge that gap between, someone grabbing like a FANUC arm with a PLC and trying to use some kind of ROS automation without leaving aside all the important things that you get from PLC type systems, like the safety mechanisms, basically, or like the real-time guarantees. So it's people trying to, like a group trying to make ROS modifications or new packages that are specifically geared towards like industrial automation.
Okay. Interesting. Coming to careers and job opportunities of robotics. So there are, as Elon Musk gave a statement about humanoid robots, they are going to be, I think, 30 billion. I don't know exact figure, but that was a huge figure that he gave about humanoid robots. And obviously, what comes into mind about the future is humanoid robots will be creating humanoid robots and that kind of stuff. Let's talk about the careers first. For a hardware specific or a software specific, what are the job opportunities for remote roles specifically?
Well, remote roles are definitely on the decline, for better or worse. One thing specifically about robotics is that you need to actually have a very specific type of role for it to make sense to be remote, right? Like for example, one of my former colleagues and friends of mine, he's able to work remotely for a company in the US and he's based in Spain because he is focused on like DevOps, right? So that's something that you don't, it's very instrumental to the company succeeding, but you can do it remotely. There are lots of companies that, basically try to strike a balance where they'll say like, if you're focusing more on like the algorithmic side, or you may be making like simulation infrastructure or like DevOps, then we'll get someone remote for the right candidate. But if you need to work on hardware, it can get pretty tough. I've had my own remote experience when I was working at Picnic Robotics, which was my last job. I'm based in Boston on the east coast of the United States, and Picnic is in Colorado, which is closer to the other side. So I was working remotely. I definitely didn't do a lot of hardware work because of that. There was some balance, but we at least had it just happened that the product we were working on had like a web dashboard, right? And because we had that dashboard where we could control the robot and, view its camera feeds, then we could do some amount of remote work. So it also boils down on like the maturity or the maturity of your stack or the type of work that you're doing. Like if if you're working in a company that's its whole identity is like remote monitoring of robots, then they probably can handle remote workers, right? Like another guy I mentored, his name's Ibrahim. He's based in India, and he works for a company in Singapore because he develops algorithms, and their company is based on like security robots and remote monitoring. So he can do that.
Do that.
In the case where you're like designing your own hardware or you have to like sit in front of the robot, then that like necessarily kind
That's not possible to some extent. So regarding the future, let's first focus on humanoid robots because that is bugging a lot of people, that this is the new thing and all other robots are going to die. Only humanoid robots are going to be the face of robotics. To learn about humanoid robots, what should be the approach?
that is even harder. So how I was complaining a little while ago about how all these things that like manipulator people take for granted are not so obvious to newcomers. I think humanoids are even worse, right? Because humanoids, and actually I have a little humanoid figure here. This is from PAL Robotics, so I've been playing with it. So humanoids, they have two other things in addition to manipulators that make them challenging, right? One of them is that, a manipulator usually is like a single kinematic chain. So you have joint one, then joint two, then joint three, so on. Humanoids, of course, have a tree of kinematics, right? So generally you have to do things like figure out where you're going to place your torso, and based on that you then figure out like where each leg is and where the arms are, and especially if you're doing something where the arms can also help with balancing, then that can become pretty tricky. Generally the algorithms become way more sophisticated to make sure that you're solving for feasible solutions, that it's not just that the motors can overcome them, but that your like center of stability based on the speed or direction you're moving at is met. And that's hard. A lot of the same techniques apply, but there's just more of it. The second thing is that, contact is unavoidable. Like for most for industrial manipulators, contact is just something you do at the end of your pick and place.
Yes.
But for humanoids, you have to make a footstep on the ground. Like you cannot get around it. So that gets into, you have to have planners and controllers that take into account that, at this time, I'm going to make contact with the ground. Therefore, I need to switch from one foot being in contact to the other foot being in contact, and then make the other foot do the swing motion that gets you to the next stable foot placement. And that is its own other thing that you don't have to worry about with mobile bases or manipulators.
Okay.
So that's what makes
But
it
for now,
challenging. As far as good resources, there's not many out there, and the reason is there's so many companies that are trying to establish that competitive advantage. We just haven't gotten to the point in the maturity of humanoids that you can just find a textbook on humanoids very easily. There's papers, there's some books, but they're not very accessible in my opinion.
This can be a good research site. Okay.
Yeah.
Interesting. So, what do you think about AI and robotics specifically? How it is going to work in production of robotics and development of robotics? We understand research will help, but
Yeah.
what do you think about integrating AI models for production quality robots? Is this happening right now?
It's certainly happening. There's obviously AI is not like a monolithic thing, so there are certain aspects of that field where people are more mature than others, right? I think a place that has really been working really well for production systems is the perception side. So, ever since convolutional neural nets became a thing, would that be over 10 years ago now? People have like found very good ways to productionalize that, right? It's super easy for you to like grab a model and fine tune it to detect the object you care about. There's now foundation models like Meta's segment anything where you can just find stuff if it's easily separated. So I think perception side, it absolutely is being used in production. Like all these like warehouse robots or assembly line robots, a lot of them are detecting parts using machine learning based perception. Obviously, the research field is moving towards other things. So there's now foundation models based on actual policies for robots, right? So the perception and language processing is like you consume sensor information and then you produce some output that then in some way has to be translated to something a robot can do, right? So for example, if you detect an object, you still have to do like motion planning to get it. So that's an engineered portion. For these like integrated policies, you don't necessarily, right? You're going directly from sensors to some output of the robot. Maybe there is some motion planning, like if your policy is, sensors to like the output of the pose of the gripper, but that absorbs a lot more into the black box of AI. And I think that we still have to figure that out as a field to make it really deployable. Like there's lots of companies that are doing this. Like recently there was that physical intelligence video that is showing, the use of large models to do things like taking out laundry. So, or I guess Figure, for example, has other examples. Are those ready for production? I don't think so. A lot of these are demos. Should people stop working on it? Absolutely not. I mean, we need the research before we get the production, right?
Yes.
The last thing I'll say is that really bugs me, and I would implore people watching this video is not to hyper focus on LLMs as the thing for robots. Like, robots are cool because they have vision sensors, they have actuators. So try to focus, if you're doing machine learning, try to focus your effort on that. Like we have enough chatbots in the world. Like you're really leaving a lot like on the table if you're just, you build a full humanoid robot and its only purpose is to like make an OpenAI call to like respond to you in natural language, So I think the embodied AI research is very promising, and we need to put a lot of effort into that because it's very interesting.
It's interesting and it's practical, more practical as well, because we don't want to just have conversations and we want robots to actually perform tasks.
Yeah, like we're good at having conversations. We're very bad at doing repetitive tasks we don't want to do. So maybe that's the problem we should focus on.
Actually, this OpenAI voice chat option is amazing and humans like it, but they don't want to do the actual work, I think, naturally. Sebastian, that's a lot of information from your side. And my goal was to make this podcast specific towards learning and core concepts in development for the robotic arms. And you have provided a lot of information and value for the viewers. Personally, for myself, it's an honor to have you on the podcast and given this much time. Thank you. Is there anything that you want to add that is left?
Well, no, first of all, I'll say thank you for having me on this podcast. I think this has been a very nice conversation. Hopefully you viewers have enjoyed my ramblings and can pick something out of it. One thing I'd say is that, robotics is very complex. This is my software colored side of things. Robotics is complex, but it doesn't mean that the software has to be complicated. So it is very underappreciated that software be, easy to use first and capable later. So anyone that is interested in that side of things, I appreciate your efforts there. I think we need to get more people doing robotics and understanding the code. So take that away.
Definitely.
And thank you.
Thank you. Thank you for this podcast.